Hello friends, this is the 11th video mechanical application of electrostatics. In this video, we should deal with some spring properties or energy stored in a spring related to a moving charge. Okay, now just to consider here. A spring is fixed at one end, this is a movable free end. Original length of the spring is of the smooth surface at the beginning. Now K naught is the force constant of the spring. Here K naught is force constant. Now just to imagine an object of mass m having charge some q is placed some distance away from the spring. Let us allow a horizontal electric field E towards right, means towards the direction of the spring. Since Q is positive, if you take, then the charge experiences a force, should say EQ, along this direction. Okay? Now the charge is gradually moving towards the spring. When it touches the spring and after that it compresses the spring provides a restoring force. Okay? At the maximum compression, you take x, the system is said to be momentarily equilibrium. Okay? The system is momentarily equilibrium. Then in that case, should say K naught x, you can take minus sign also, that equal to EQ. So from this, x is written as a EQ divided by M. This is the expression of EQ divided by K naught. This is the expression for maximum compression in this spring. Okay. Now, when the spring starts from here, its velocity is initially v at any instant, should say t equal to 0, and at a certain time at t equal to t, the spring compressed maximum, means equilibrium, means v equal to final velocity is 0. Now you can use energy conservation. Okay, you can use energy conservation, that is half m into v square minus 0 square. This is final k and this is initial k. You take this is final and this is initial. Loss of kinetic energy, that is equal to half k naught into x square. That is gain in electrostatic potential energy. Okay, loss of kinetic equal to gain in electrostatic potential energy. So from that you can find out what is v, velocity required. You minus sign you can omit. This is k naught x square divided by m. Okay, this is the magnitude of speed. Omit minus sign because one energy lost, another energy is gained, and if you put here minus k naught, then minus will absorb here. So now k naught x square divided by m, you can got an equation. Okay. Now if m is unknown or v is unknown, you can find out the values by using this equation. Okay. Now again, what is the value of x? If you put the value of x, this is k naught by m into x square. Here x square means e square q square divided by k naught square. So therefore you take v square equal to e square q square divided by m into k naught. M into k naught. This is in terms of, okay, electric field. In LHS, this is velocity. You take a small here. In LHS, you take velocity. Now V square equal to E square Q square plus M K naught. That means if all others are given except E, you can find out the value of E, means what should be the electric field required, so that the charge will accelerate this much distance. Okay. Now similarly other properties you can calculate. Okay. On the other hand, if length of the electric field is up to this much, same distance should say L equal to S, length of the electric field. Okay. Then what is E? E is potential distance divided by length. This V is called electric potential. Okay. Electric potential. Now if you compare find out the relation, if you want to find out the relation between the potential and V, okay, then put here V square equal to capital V square divided by L square, Q square divided by MK naught. Okay. Now this L is nothing but distance traveled by the charge. Okay. Now if you consider the same situation here, but the surface is rough, that is coefficient of friction is mu. That means here forward force is EQ, backward force is mu mg, forward minus backward, that is equal to your resultant force. This will be the equation in this case. Okay, EQ minus mg, that is equal to ma, and this is nothing but k naught x. This ma is nothing but k naught x. So what is x? This is EQ minus mu mg. Mu is coefficient of friction, whole divided by k naught. Okay, this is the value, and if you put this value, that is in this equation, energy conservation equation, then you can find out the relation between some other physical quantities in the presence of friction. This is in the presence smooth surface, and this is in the presence of a friction. And a problem for you, let us try. That is, you take Q1 equal to, should say 10 microcoulomb. That is M equal to, you take, that is 100 gram. Okay, that is K naught equal to 100 SI units. That is Newton per meter. Okay, Newton per meter. Then mu is, should say you take 0.2. Okay, all are given. So find out the value of electric field. Find out the value of electric field, or find out the value of V, velocity. Okay, and this is a sum value. Okay. Now finally, this type of calculation we have already discussed earlier in one of my video. This is a not vertical field, because in a vertical field plus minus electric field, vertical field here effect of gravity is there. In a vertical field, effect of gravity is there, but I am taking this is a horizontal field. You can take this side as a plus side, better, for better understanding. You can take this side as a minus. This is a ground. This side is a plus. This side is a minus, and this is the direction of electric field. Mark. This is the direction of electric field. That is parallel to ground. I do not want to take the effect of gravity. Okay. Now a charge Q of and mass M. So this is the direction of electric field. This is E. I am writing. Enters into the field with the speed u, that is taken as a ux. Now electric field is perpendicular to motion, so we know that if the force is perpendicular to the motion, then it has no component along horizontal, therefore ux is uniform, and the charge gains some velocity along vertical direction, that is towards E, and its initial velocity towards E is 0. Okay, that means uy is 0, and gradually when the force is perpendicular to the motion, then the path is a parabolic. Path is a trajectory, and the charged particle describes this type of a motion in the electric field. Okay, it describes this type of a motion. Now, if this is the case, then that is you can write at any instant horizontal distance traveled. Suppose this is the horizontal distance I am taking, x equal to L. So x equal to L, that is ux into t, or x equal to, write in the equation form, you write ut. This is your equation form. We have discussed this type of a question earlier. Okay, but what is the importance in this case? Just we are going to discuss. Now, what is the equation of vertical path? That is y equal to ut plus half. Okay, half a means eq divided by n into t square. This is half eq by n. T means x by u. This is x square divided by u square. So this is your formula. eq divided by m, x by u, sorry, x square. Okay, x square by u square. So now y, this total is a constant quantity. So this equation is y is kx square. This equation is in the form. So the path is parabola. We know that the path is parabola. That means the equation deviates away from its initial path. Now at any point, if you want, what is the deviation? Let angle theta. Somewhere here, what is the deviation? You draw a tangent. This angle is theta. Therefore, the vertical displacement here, this is y1. Here, this is y2. The vertical displacement shows you the angle of deviation. Okay, so y shows the angle of deviation. So this is your important equation. Then that is, let us convert this equation into some other form. What is, I am writing this equation is y. Okay, see, this is eq, normal term eq. Okay, now this term is 1 by 2, sorry, this is 2 in the denominator. Here there is a mu square. So I am writing 2 into half mu square. Here I multiply with 2, dividing with 2. There is a 2. This is 2 multiplying, dividing into x square. Okay. So this represents your eq divided by 4 times. This is a kinetic energy into x square. Therefore, if you take two charges, should say one proton, one another electron. If both the charges accelerates, or one proton, another alpha particle, both moves along same direction. Suppose condition is they possesses equal k. If they possesses equal k, then there is y for which physical quantity is large, because here y depends upon q. Okay, y depends on q. Therefore, y depends on q because kinetic energy is same. Or if q is known, y is known, what is the kinetic energy at any instant after traveling some distance x? You can calculate. So this is a relation with respect to kinetic energy, and y represents your vertical distance. At the same time, it gives you the angle of deviation indirectly. Okay, because we know that tan theta equal to y by x. Okay, tan theta equal to y by x. So y equal to x tan theta. Okay, now another form you can write, this is y equal to eq. Same equation I am giving eq. Okay, this is a 2 term, that is m square u square. I am giving a bracket. There is a m, but I am writing m square. So you write 1m multiplied with. Okay, and this is written as a eq divided by 2p square m into x square. What is p? P is your momentum, linear momentum. If p is linear momentum, then y can be expressed in terms of p square. Then y inversely proportional to p square. If you take same two particle, either electron proton or proton and alpha particle, both possesses initially same momentum same. So which deviation of which particle is a large? If y is a large, deviation is a large. If y is a small, deviation is a small. Okay. So these are the relations, vertical distance with respect to kinetic energy and momentum. Okay. Now if you like it, like कीजिए, subscribe कीजिए, so that I will upload more and more videos. Thank you.